So we are looking at a certain K2SO4 dot aluminium 2 into bracket SO4 free dot 24 H2O. So when we're given something like this, immediately we see this structure, you realize that it contains two cations. The first cation is this one, and this one. I hope you've seen it. Oh, have you not seen it? It contains this. The aluminum is one cation, and this one is also another cation joined together, and this one is this mixture. This one is another mixture. When we bring them together, we form something called double salt. We can simply write this one too like this. You realize that they all have SO4. So we can also simply write this one KAL aluminum KL into bracket SO the bracket SO for bracket close. SO4 bracket close. Then we add 2. The 2 shows that there are 2. You realize that this and this there are 2. And you realize that the SOs, these SOs are 2. So you can just simply write potassium aluminum. We can, so this one can be potassium or aluminum potassium base tetraozosulfate. Base tetraozosulfate dodecahydrate. So if you have to name this two, this will be the name. You know, this H2O stands for water, so we name it hydrate. Hydrate. The whole of this is in water, so we call this is hydrate. And this is aluminum. This is potassium. So because the aluminum has alphabetically counts first, you say aluminum, potassium, base. When we say base, then that means bi, or base. So base tetraozosulfate. That means 2 of tetraozosulfate. That means 2 of tetraozosulfate, and you find that this in it's into bracket VI. The VI is its oxidation number. Then you add, you know, this is 24. So if it's 24, then that means this will be dodeca. Sorry, this one is dot. This dot. When we do rearrangement, we can get something like this. Simply, we can get something like this. That means we've reduced it. And so the dodeca is 12. Sorry. So we are going to get this. So the dodecahydrate. The dodeca means it's 12. Deca is 10. And the do means 2. So 2, 12. So 12 dodecahydrate. In simple terms, we can call the whole of this potash alum. We can call the whole of this potash alum. The double salt, when you see it and you're unable to name it, this potassium. So you just look at it and so these are the 2 ways we can write this.
So we'll name it.
Is that, oh no. Normally when you're asked to, they'll just tell you to, if it's an acid and base, then they'll tell you to give examples of maybe double salt. Then you just write it, potash alum, or you can simply write it this thing. I don't know, maybe you only name it, maybe it will be OBJ. Now we can also consider another example. We can also consider another example. We have iron ammonium alum. Iron 2 ammonium alum. Iron 2 ammonium alum. Iron 2 ammonium alum. Iron 2 ammonium alum. Then we can also get chrome alum. Chrome alum. Chrome alum. Now the iron 2 ammonium alum. It's a combination of this. So this is it. This is the iron, and there's the ammonium. NH 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 for into brackets 2. Then into brackets SO4. That's the chemical name of it. Dot. Hey, Aquaba, tell me, welcome, man. Dot H2SO. Sorry. Please, there's noise at the background, eh? So we have this. This is the iron alum. Iron 2 ammonium alum. Iron 2 ammonium ion. If you want the name, it is long. The name is diammonium ion. The di is coming from this. The di, diammonium alum. Diammonium alum. Diammonium alum 2 bis tetraozosulfate VI hexahydrate. So the naming is starting from here. So diammonium. So this is two twice of or double of ammonium. So diammonium ion. So you find the distance. We find for what the oxidation number, which is 2. And so diammonium alum. Diammonium ion 2. Then you know that this one is 2. The whole this is 2. And so this is base. We are using a base because they are all this thing. They are all, the base stands for 2, but we can't use di here because the di and the tetra, they are all prefix or numbers. So we can just use the base. Normally when you are talking about twice of something containing an already prefix or something. So this one become base hyphen tetraozosulfate. This is tetraozosulfate. So the base means twice of this tetraozosulfate. And its oxidation number is Vi into brackets Vi. Then we conclude with this is hexa, the 6 is hexa, and the water is hydrate. So hexahydrate. So you just tell the person this is diammonium ion 2 base tetra Vi hexa, what do you call it? Hexahydrate. You should be able to understand. That's why I've taken my time to break down. This is the hexahydrate. That means 6 of water, 6 water. The hexa is 6, and the 2 is the base, and the tetraozosulfate is this one, tetraozosulfate. So base hyphen tetraozosulfate, and this one is the 2. So this is iron, this is ammonium, and it's twice of ammonium or 2 ammonium. So I'm going to get diammonium ion. So this is diammonium ion. Then you can continue. So that is it. You can go and read more. Now let's consider the last one. We are going to this thing. Complex salts. Complex salts. Complex salts. Complex salts. Hold on, please. Let me fix plastic chair now.
Yes, sir.
So complex salts. So complex salts. We are saying that every complex salt Every complex salt. Every complex salt. Every complex salt. Every complex salt contains a complex cation. It contains a complex cation or anion as a stable species. As a stable species. Every complex salt contains a complex cation. Because it is complex, it contains a complex cation or an anion as a stable species. And it normally has a central metal ion. It normally has a central metal ion, which is surrounded by the species called ligands. So let's consider one or two examples. Maybe just one example will do. So you can have something like this. You can have K free. One example is K free. You can have K free Fe. You can have K free Fe, which is potassium ion. No. Fe.
Ionite.
Into bracket Cn. Who can give me the name of Cn? Who can give me the name of Cn?
Cyanide. Cyanide.
What?
Cyanide.
Okay, cyanide. Cyanide. So not cyanide. Cyanide. Simple. God bless you so much, and grant you a good girl tomorrow. Yeah. So one example is this. So this one, the one we have to name this will become potassium. There's a potassium. Potassium hexacyanoferrite. Hexacyanoferrite. Free. The ferrite means iron, it's the same thing. So this one will be potassium. Potassium hexacyano. Potassium hydrocyanoferrite. The pharmacists, the way they are suffering, master. All these names, you have to know it. How they came about. So there's one example of complex salts. You can go and look out for the rest. You can also have, let me just write. You can also have lithium. You can also have lithium, aluminum, and hydrogen 4. So you can have something like this. Sorry, this is common. You normally see it in your exams. I don't know. Normally see it in your exams. H4. Who can name this one for me? Who can name this one for me? Bene, help me with this one. LiAlH4. Who can name this one for me?
Sir, please, I can't.
Okay. Nana Yadoku. Try.
Sir.
Hey, who have been with you? There's the name. Lithium tetrahydroaluminate. Aluminate. And then you mention it, that's a you're ending, that's a you're not ending. Lithium tetrahydro. Okay. Aluminate. So that's it. That's the name for this. Now we are done with the types of this thing. So we looked at the types of salts. We looked at the normal salts where the replaceable hydrogen is replaced wholly with what do you call it? Cation, metal cation. We looked at that, and we looked at the acidic salt where the replaceable ion or the replaceable hydrogen is replaced partially or partly. We look at that, and we looked at the basic salts. We looked at that. That contains, number one, it contains the O's or the OH. After that, it contains what we call the O's, I mean the oxides and the hydroxides. It contains what we call the metallic ions, and we look at it also contains the negative ions of the acid. We looked at that, and from there, yeah, Ruben, talk to me. And from there, we looked at the double salt.
Which one can be used for cooking?
Oh, the normal salt. The normal salt. Like the sodium chloride, which we've been using for cooking already. The saltpeter, we use it. Don't we use kiln?
Yes.
Potassium chloride, they are all normal salts. They are all common salts, so we can be using those ones. And even chalk, it is not really harmful. But the complex and the rest, I don't know what you can use them for. Now let's look out for. So we are done. We are talking about neutralization. Neutralization. You know, when you have your butter friend here, you always be buying. When I see their faces, then I start buying. Enemy of progress. Neutralization. So you all know what neutralization means. When we say neutralization, it's a reaction between basic, yes, an acid and base, or basic oxides or hydroxides and an acid. So the reaction between an acid and a base, or basic oxides, or hydroxides and acids are termed as neutralization reaction, or the reaction is called a neutralization. And normally when the reaction is done, normally the byproducts are salts and what?
Water.
Yes, the main byproduct is normally water. Now, we are going to classify oxides, classification of oxides. So we understand what neutralization is. Now let's classify oxides. Under the neutralization, we are going to talk about classification of oxides. When the class ends, then we are done for the day. Back is aching. Classification of oxide. Now there are three major types of oxide. I think we spoke about that the other time. We have the basic oxides, we have the acidic oxide, we have the amphoteric oxide. The other day I explained what amphoteric means. Maureen, what did I say? Amphoteric. I explained what amphoteric means. I would say a compound is amphoteric. I explained it the other time. Maureen, what did I say? Barcelona.
So you said there are species and say you said there are species that behave as base and acid at the same time.
Oh, Lino Nessi. Messi, Charlie, you're good, what? Messi na Kasano. You're good. God bless you. I thought you listen like how, but I put your good small. So amphoteric oxides, and we have the neutral oxides. So we have three main types or three main classes of oxides. We have the basic oxides, we have the acidic oxides, we have the amphoteric oxides, and we have the neutral oxides. Now we are saying that let's first take the basic and other. We also have other oxides, which are normally peroxides and mixed oxides. When we get to there, you understand. So you realize that you attack hydrogen peroxide and the rest. they also another type of this. But the main four classes of oxides or types of oxides are the basic oxides, acidic oxides, amphoteric oxides, and neutral oxides. And this, if I don't even teach you and you go to the examination, you should be able to define it. Just looking at the title, basic oxide, then definitely you know it will have a certain basic feature in it. Acidic will definitely have a certain acidic feature in it. Amphoteric, that means it will be an oxide that does not behave like an acid or a base. And the neutral, that one on the he's, should I use the word impervious? It doesn't react to anything. So let's explain them. Now, when we say a basic oxide, we are saying that a basic oxide is a metallic oxide which reacts with an acid to produce salt and water. So a basic oxide will react with an acid to produce salt and water. So it's a metallic oxide which will react with an acid to produce salt and water. So normally when we say oxides, then we are just trying to say those compounds that has oxygen in them, like copper oxide, sodium oxide, calcium oxide, magnesium oxide. These are all oxides. Now the basic oxides are metallic oxides. So copper oxide, CuO, is metallic oxide. That means it has the copper is the metal and the O is the oxygen. And so when they come together, we call it metallic oxide. And so this one, when they react with an acid, it always gives you salt and water. Now, if it was to be maybe NaOH, then it ceases to be oxide. Now it becomes metallic hydroxide. That's what it means. So now, when we say basic oxide, I'm saying that these are metallic oxide which react with an acid to produce salt and water. And so, and if soluble in water, it forms an alkali or alkaline solution. So when you have calcium oxide plus hydrochloric acid, you are going to get calcium chloride plus water. When you have copper oxide plus or when you have calcium oxide plus water, you are going to get calcium hydroxide, which is an alkaline solution. The alkaline solution is more or less like a metallic hydroxide. Bisano. That is it. I explained that the other time. Now let's talk about the acidic oxide. When we say an acidic oxide, then I say that it's a non-metallic oxide. It's a non-metallic oxide, which when combined with the elements of water produces an acid. It's a non-metallic oxide, which when combined with the elements of water produces an acid. So that means an acidic oxide is a non-metallic oxide. That means that one, it has no metal in it. It's a non-metallic oxide, which when combined with the elements of water produces an acid. So for instance, you realize that when I was teaching in our previous lesson, before the call, the class ended, you realize that I told you when you have NaSO4, this one is an anion of the acid, and this one is a metal part. So now if I'm to take this one, if I'm to take this one, this SO4 is a non-metallic oxide. It has no metal in it, so it's a non-metallic oxide. Now, when it is added to what we call H2, or when it is dissolved in water, it gives us an acid. It will give us an acid. And who can tell me what the name of the acid it will give? Sodium and water. Sulfate and water. What are we getting? Who can name the acid? You're going to get what?
H2SO.
H2SO4. So we are saying that this is a non-metallic oxide. When it reacts with water, it will give you acid. So this oxide is called acidic oxide. Because when it reacts to this, it will give you acid. So it is called acidic oxide. Now let's talk about amphoteric oxide. Amphoteric. Ampho. It's a nice name. You can even name your child after it. Or you don't believe? Oh, my Voltarians, they can do it. The Voltarians, they can do it.
No.
You said no.
No.
Aren't you the people who have been naming people, listen, God is love and I'm coming home and there is freedom and justice. When they are twins, am I lying? When they are twins, they call them rules and regulations. So the first one
That
is
is
rules,
true.
and the other one is regulations. They can be freedom and justice when they have two, freedom and justice. When they are girls, peace and love. You can ask peace and love.
Beauty and innocence.
Beauty and innocence, you get it. Character and efficiency, you get it. They can name someone Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Israel, Egypt, America. They can use to name anyone. And what's so fascinating about them is that the way they can use a whole sentence to name someone. God is coming. God is coming. I'm coming home. We are going to heaven. Heaven is my home. Jesus is coming soon. Jesus is coming soon. The one lady cry ahead. One lady, Metinidi. Her name is Save the Date. Save the Date.
Hey.
Hey, so save the date. Ash, am I lying? Am I lying?
No, sir.
I don't lie, but students, you know them. So they can name you after their destiny. Just that most of them are not science students. So they can name amphoteric oxide. It won't be anything. Or maybe it's too short for them. So maybe they'll go for the double salt. Aluminium, potassium, base tetraoxosorbate, do they hydrate potash alum, and then call you. So when we say amphoteric, we are saying that these are oxides which can show both basic and acidic properties. So they can show both acidic and basic properties. So it can react with both acid and alkali to produce salt and water only. So example of amphoteric oxides are zinc oxide. Zinc oxide. It can behave like an acid, it can behave like a salt. One example is zinc oxide. Another example is aluminum oxide, Al2O3, aluminum oxide. You can also get thin oxide. Thin oxide is SNO, thin oxide. And you can get PBO. Who can give me the name for PBO? What is PB?
Lead.
What?
Lead.
Public what? Public oxygen. It's what? Chili. PB. Chili, what is PB?
Lead.
Lead. So lead oxide. And BeO. Who can name BeO? What is BeO?
Beryllium.
This one, the Voltaireans can pronounce it better. The Ashanti is a no. The Ashanti is a please don't try. You hear the beryllium oxide. So BeO, myself, I don't want to try it because I'll end up disgracing myself. So the beryllium oxide, my brain rough. So these are examples of amphoteric oxides. They have both basic and acidic properties. Now let's consider the last one. Neutral oxide. Neutral. Now a neutral oxide is an oxide which shows neither basic or acidic character. It shows neither basic or acidic character. It shows neither basic or non-acidic character. Example, carbon dioxide. I've seen a Voltairean being called carbon dioxide before. That one there is no lie. Carbon dioxide. Oh, carbon 2 oxide. That one is carbon monoxide rather. Sorry, carbon monoxide. CO. Carbon monoxide. Nitrogen oxide. N2O. Oh, I've seen a bacterium called this in carbon monoxide before. They were two. The first one is carbon dioxide, and the second one is carbon monoxide.
Say.
And we have nitrogen oxide. Nitrogen oxide. And we have water. But you know one thing about the Fantis, when they have been bringing the new names. For instance, if you're a guy and you are called water, they'll call, if you're a lady, they'll call it watara. You know that. If you are Sandra, then they want to Sandrina and the rest. You know that the Fantis have been doing those things. Benjamin Mina, you know. That means the female of Benjamin. The Fantasy. Oh, Maury, am I lying?
That is one day.
Oh, carbon dioxide. You know, the Fantasy can do that. They have been using the AA, adding the AA to the names. Emanuela. Initially was Emmanuel. In the Bible, there's nobody called Emanuela. But the Fantasy brought that name, Emanuela. If Robert, then they said Roberta. Oh, you can Daniel is a Daniela. Everything will add it to it. So me, my first born will be Kopak, and the second boy, the girl will be Kopak Lina, you know, or Kopak Len. So I have some fancy blood in it. So, and we have the peroxides. These oxides react with dilute acids to form hydrogen peroxide. So they react with dilute acids to form hydrogen peroxide. And I am the teeth one of my friends say mouthwash now. Yeah, some of the examples of peroxides. These oxides react with dilute acids to form hydrogen peroxides. Example is sodium peroxide. Normally the peroxides, sodium peroxide, it is Na2O2. Na2O2. Sodium peroxide. And you can also have barium oxide. BaSO2. Barium oxide. Not barium, please. Barium, not barium. Barium. When I leave her, she'll say it right now. Maybe she's an Ashanti. When she's typing Barcelona, say Barcelona. And the last one, mixed oxide. Mixed oxide. Oxide now you have frafra. Mixed oxide. That is the frafra version of oxide. It is made up of two oxides. Example is Fe3O4. Fe3O4. That means iron. Is it oxide? I nearly said oxide. So it's the iron. Listen, the Fe3O4 is a combination of. We are done. It's a combination of FeO and Fe2O3. There's a combination of the two. That will give you the Fe3O4. And its name is iron 2 diiron free oxide. Iron 2 diiron free oxide. That means the ions are 2 diiron free oxide. So this brings us to the end of today's class. Please, the Voltarians, don't go and do me anything, I beg. I was just playing. Save the date. I'm coming home. God is love. I'm returning from my journey. Mommy is coming home.